In the realm of science and cosmic mysteries, the question of what existed before the Big Bang has stirred debates and intrigued minds for centuries. This profound question doesn't just challenge our understanding of the universe. It challenges the very boundaries of human knowledge. Imagine standing at the edge of existence, staring into the vast darkness and wondering what lay there before our universe was born. The moment of the Big Bang marked the beginning of time, space, and everything we know, but was there a moment before this? Could there have been a state of nothingness, a silence before the cosmic orchestra began? And if so, what was it? Or perhaps there was something far more terrifying that existed before time itself. As we dive deeper into this question, science takes us on a journey beyond the universe's origin into concepts that defy our understanding. Physicist Brian Cox, known for his exploration into the wonders of the universe, suggests that something terrifying might have existed before the Big Bang. He challenges us to rethink our concept of reality, time, and space. In this exploration, we'll examine the science, the theories, and the jaw-dropping mysteries that might explain what existed before everything. We'll look into ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we've uncovered might just shock you, but they could also unlock new understandings of our place in the cosmos. Get ready to dive deep into a world beyond imagination and science, where the unknown still looms in the shadows, leaving scientists astounded and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to carefully examine what the Big Bang actually was. The Big Bang, as scientists define it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to set off the creation of all matter, energy, and cosmic forces. When we look up at the night sky, we see evidence of this hot beginning, with galaxies spreading out in all directions from a central point. But why did this happen, and was there a time before this dense, hot origin? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or peaceful. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched out almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained an immense amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the groundwork for everything that would follow. In a fraction of a second, space stretched at speeds beyond comprehension until the expansion slowed, and the energy transformed into matter, particles, and the forces we recognize as the Big Bang. But what was the nature of this energy? Why did it suddenly inflate the universe, and why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there. Each bubble represents a universe, including ours. This concept, called the inflationary multiverse, implies that there are potentially infinite Big Bangs and an endless number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the universe itself and leaves us with the question: what else is out there? The concept of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an inescapable tapestry of something, even in its most vacant form. Even if we imagine stripping away all these forces, leaving a dark void, the universe would still create new forms of energy. This fact alone is baffling to scientists, as it suggests that true nothingness might be impossible within our cosmic understanding. As we probe deeper, we find that space itself has properties, rules, and constants that do not allow it to be completely void. Imagine creating a region with absolutely nothing in it, no particles, no radiation, and no energy, but quantum fields and fundamental constants still exist, meaning that this nothingness has properties. For instance, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still briefly appear and disappear, creating a ghostly echo of activity, even in what should be empty space. This defies our concept of a true void and suggests that, even before the Big Bang, there was something that scientists are only beginning to understand. One of the most astounding theories in modern cosmology is the idea of eternal inflation. If inflation could cause our universe to exist, it's possible it could continue indefinitely. Brian Cox describes a terrifyingly vast inflationary multiverse where universes are endlessly created and continue expanding. Imagine each Big Bang as a spark igniting a new universe, while inflation persists in other areas, creating countless other universes. This process could, in theory, go on forever. This idea of infinite universes gives birth to a fascinating concept of a fractal universe, where every new universe has the potential to create its own Big Bang. Each universe exists as a separate, self-contained realm, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests an endless multiverse with no ultimate beginning or end. What if our universe is just one speck in a colossal cosmic structure, expanding and creating forever? And what if the terrifying truth is that there is no before or after, but simply an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. Instead, it's a network of energy fields that fill the cosmos, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as ripples, waves, or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, borrowing energy temporarily before returning it. This phenomenon gives rise to virtual particles, entities that briefly exist and then vanish, leaving behind a faint memory of their presence. The concept of virtual particles challenges the notion of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have complete nothingness? According to quantum field theory, you would not. Even in a vacuum, fields would remain active, occasionally producing fleeting particles. This constant activity in what should be nothing suggests that the universe doesn't understand our concept of emptiness. The fields and forces persist, filling the universe with an underlying energy that prevents absolute nothingness. This insight raises an intriguing question. If fields create particles and particles create matter, then could the universe itself have emerged from this nothingness, filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to scientists, it's possible that the dark energy we observe today is a remnant of an energy field from before our universe's formation. Dark energy's properties seem to suggest a vast hidden power that could have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, could have powered the inflationary phase, allowing for rapid expansion. The presence of dark energy implies that even if our universe were emptied of all matter and radiation, this force would continue to stretch the fabric of space-time. This idea leads to an unsettling thought. If dark energy was present before the Big Bang, it might have shaped the conditions that led to the birth of our universe. Could dark energy be the silent architect of cosmic inflation, or even the true origin of our universe? As we explore this possibility, we confront the potential of dark energy not only as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, the idea that the universe goes through endless cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but rather part of a cosmic rhythm where universes expand, collapse, and then re-expand in a new cycle. This theory proposes that our universe might have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but instead an infinite sequence of universes emerging, evolving, and renewing themselves over and over. Cyclic cosmology raises profound questions about time, as it suggests that time itself might be circular rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers an elegant solution to the question of ultimate origins by suggesting that there isn't one. Instead, the cosmos has always existed in one form or another, transcending our notions of time and existence. Primordial gravitational waves are another fascinating concept that might hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe that primordial waves, if detected, could reveal details of the universe's earliest moments. These waves would be remnants from the inflationary period, carrying information about what happened during the first fraction of a second after the Big Bang. But what if there were waves that predate even the Big Bang? Some theories propose that gravitational waves could exist from a pre-Big Bang era. If such an era existed, detecting these waves could provide direct evidence of events or conditions that occurred before inflation and the hot Big Bang. However, finding primordial waves from before the Big Bang is an enormous challenge. Scientists are developing sensitive instruments to detect these subtle ripples, hoping they will one day reveal a hidden layer of cosmic history. Such a discovery would not only provide answers about our universe's infancy, but also about the deeper cosmic forces that might have sparked its existence. Quantum foam, a concept proposed by physicist John Wheeler, is another theory that hints at the possibility of pre-Big Bang existence. According to quantum mechanics, space is not truly empty but is filled with constant fluctuations of energy at the smallest scales. This quantum foam suggests that at the tiniest scales of space and time, particles can appear and disappear in fleeting moments, giving rise to temporary bubbles of energy. This idea supports the vacuum genesis hypothesis, which posits that the universe could have emerged from a large quantum fluctuation in the sea of quantum foam. The vacuum genesis hypothesis proposes that what we perceive as the Big Bang might actually have been one of these energy fluctuations, growing until it became the universe. This view redefines the concept of nothingness, proposing that even in the absence of matter, energy, and traditional spacetime, there still exists a dynamic reality. If our universe is indeed the result of a fluctuation in quantum foam, then there might be other universes appearing and disappearing within this quantum sea. This notion expands the multiverse theory and suggests that our universe's existence may be far more ordinary in the grand scheme of cosmic phenomena. Quantum tunneling is a phenomenon in quantum mechanics where particles can pass through energy barriers even when they don't seemingly have enough energy to do so. This concept of tunneling is intriguing when applied to the universe itself. Some cosmologists propose that our universe could have tunneled into existence from another dimension or reality. Quantum tunneling would allow energy to breach an otherwise insurmountable boundary, resulting in a universe emerging from another plane of existence. This theory adds a mysterious layer to the idea of what existed before the Big Bang, as it implies that our universe could have leaked or tunneled into being from an alternate realm. If this theory holds any truth, then our universe could be just one of many that form, evolve, and vanish within a much larger hidden structure. Quantum tunneling suggests that the Big Bang might not be the beginning, but rather the result of a boundary being crossed, a moment when our universe emerged into the vast unknown. As we explore these theories, it becomes clear that our understanding of the universe's origins is limited but evolving. The Big Bang was once considered the ultimate beginning, the singular point from which all existence sprang. But now, with concepts like inflation, the multiverse, and quantum fields, we see a much more intricate tapestry. Scientists like Brian Cox push us to imagine that something existed before our universe, something powerful enough to ignite the Big Bang and set off the chain of events leading to our existence. The implications of these theories are both exciting and humbling, reminding us that the universe is full of mysteries yet to be solved. So, what existed before the Big Bang? While science may one day reveal more answers, for now, we stand at the edge of what we know, peering into the unknown with curiosity, awe, and a bit of fear. The vastness of the cosmos, its intricate designs, and the mysteries it holds remind us that our place in the universe is both remarkable and fleeting. Embracing this mystery is part of what makes us human and inspires us to continue exploring. As we continue to explore the mysteries of what may have existed before the Big Bang, it's essential to consider the role of theoretical physics in shaping our understanding. While the concepts of quantum mechanics, inflation, and the multiverse provide compelling theories, they all point toward a fundamental idea. the universe is far more complex than we initially imagined. The very nature of time, space, and reality itself seems to be much more fluid than our everyday experiences would suggest. One fascinating idea in this realm is the concept of time as we know it, which may not have existed before the Big Bang. In some interpretations of physics, particularly those relating to quantum gravity and string theory, time is considered an emergent property of the universe, rather than a fundamental, intrinsic aspect of reality. If this is true, then time itself may have come into being only when the conditions for space and matter were set in motion during the Big Bang. Before this moment, there may not have been a before at all, no chronology or sequence, only a timeless state that defies human comprehension. Moreover, some cosmologists speculate that the very laws of physics as we understand them may not have applied before the Big Bang. In such a pre-universe state, the principles of causality, which govern how events unfold, might not have been in effect. This leads to the mind-bending possibility that the usual rules of cause and effect, which guide our perception of reality, could be entirely different or irrelevant in this primordial state. In this view, the Big Bang may not be a single, unique event, but rather a part of an ongoing cyclical process of cosmic evolution. This aligns with the idea of a big bounce, where the universe contracts to a singularity before expanding once more. Such a theory offers a potential solution to the question of ultimate origins, suggesting that the universe's birth may have been preceded by a prior cosmic contraction, leading to a never-ending cycle of birth, death, and rebirth. These ideas underscore the limits of human knowledge but also highlight how close we are to possibly uncovering a new chapter in our understanding of the cosmos. Each new discovery, whether through the detection of primordial gravitational waves, further study of quantum fields, or theoretical advancements in string theory, could one day offer us insights into the nature of existence itself. The journey toward these answers may not be immediate, but the pursuit remains one of the most exciting endeavors in science today.